Hello, everybody. My name is Debashish Roy. I'm the Senior Network Trainer as well as Cisco Networking Specialist at the Indian Cyber Security Solutions. And these are my contact informations for LinkedIn, Twitter, and Facebook in case you want to contact me. Today, the topic is redistribution. So this is a routing topic from CCNP, Cisco Certified Network Professional. That is an excellent course for building a sound career in Cisco networking. So what is redistribution? So we already know that routers have their routing tables and they actually are configured with some different routing protocols. Now, it may be that company A is running one protocol and company B is running a separate routing protocol. So enterprises may run different routing protocols in their different regions or different offices. So, for example, if you do not want to go for static routing, so in that case, you will have a choice only for redistribution because you are running two different protocols into different regions. Say one region is running OSPF, another region is running EIGRP or BGP. So how can you connect? Because routers cannot directly connect between two protocols. Yes, so routers have no other choice but to go for redistribution or to go for static routing. But as we know that when your networks go and they grow considerably, then you cannot go for static routing because it is very time consuming and tedious to maintain all those static routes. So you have to go for dynamic routing and you have to go for redistribution. So what is the meaning of redistribution? Redistribution means that taking something, taking say part A, part 1, and to inject that part into some different matter. Means redistribution is a method to inject any external route into a certain domain and you are injecting some other routing protocol route, say from EIGRP to that OSPF, or you are running EIGRP domain and you have a OSPF domain, so you are actually injecting OSPF routes into that EIGRP domain. So that is the mutual redistribution, and we need to do it between two routing protocols like EIGRP, OSPF, BGP, all these protocols. So redistribution is used when two companies merge. Yes, if they have two companies, two different companies, and they're merging, and the problem is that one company is using, say, for example, EIGRP, and the other company is using OSPF, and they will not change it because that is already configured in our routing infrastructure of that company. So they cannot change that. So in that case, you have to mutually redistribute the routes into one another company. So they're running different routing protocols. So you have no other choice but to redistribute EIGRP to OSPF and OSPF to EIGRP. Now, redistribution example. So I've already told you that EIGRP and OSPF can be used for mutual redistribution to inject routes. Mutual means both will insert routes to each other's domain. And we already know that EIGRP and OSPF both have a concept of autonomous system or AS. Now, what is AS? We already know that AS is a logical boundary area where all the routers reside, and they are called neighbor routers. And in the OSPF, the AS is divided into several areas. Redistribution to be configured on the ASBR or Autonomous System Boundary Router. Yes, so this is the router which is placed on the boundary between two routing domains. So that is the ASBR that is connecting between two AS. One is EIGRP AS and the other is OSPF AS. So that resides on the boundary of those two routing protocols, and the redistribution is totally done by the ASBR. Now, in case of you are redistributing OSPF routes in EIGRP, some points you have to remember. That is, for redistribution between OSPF and EIGRP, if you are redistributing OSPF routes in EIGRP domain, then the K values must be specified. Now, what are the K values? We already know that there are 5 K values, K5. What are those? Bandwidth, delay, load, reliability, and MTU. MTU means the maximum transmission unit, or that is the packet size. In case of Ethernet, it is 64 bytes to 1500 bytes, that we already know. So you have to specify those K5 values, K values, if you are injecting routes in EIGRP, otherwise it won't show. But if you are injecting from any other routing protocol to OSPF, then the K values need not to be specified. So this is the example, the diagram, should I say, of the redistribution. There is a EIGRP AS12 and also an OSPF. And so we have a router 1, router 2, and router 3. Router 1 is totally running EIGRP domain, EIGRP AS, and router 3 is running OSPF. You have loopback interfaces on router 1 as 111, and on router 3 you have loopback as 333. So you will insert those loopback interfaces in the respective routing domains. And here the ASBR is R2. That is in the boundary between the EIGRP and OSPF. So redistribution should be configured on R2 router. So here the R2 acts as the ASBR that I've already told you between EIGRP and OSPF domains. Now, what are the type of LSA that is injected to redistribute routes into OSPF domains? Type 5 LSA. That is a type 5, that is external LSA. External LSA, external type 5 LSA, because it is redistributing or is coming from other domains, other router domains, from EIGRP or from BGP, is coming to OSPF. So that is definitely an external type LSA and external type 5. By default, external type 2 E2 route is injected to OSPF domain. So we already know that in OSPF there are 2 routes, that is E1 and E2. So type 5, in case of type 5, there are also external type 2 E2 or E1. So by default, the E2 route is injected to OSPF domain. And we already know that E2 route is that route where the cost is not incremented. So say, for example, some routers are passing the E2 routes. So we are not actually calculating the cost of the intermediate routers. So that is the external type 2 route. And external type 1 is where we are adding the cost of the intermediate routes. So the cost increases. But by default, the external type 2 E2 route is injected into OSPF domain. Now, redistribution can be manipulated or can be, you can say, fine-tuned using route map also. Now, what are the route maps? We have already done the ACL access control list in CCNA level. So route maps are also like ACL. It is like ACL. It is not ACL, but it is more descriptive than ACL. Route maps have many options than ACL, I should say. But it is like the conditional statements, like the access control list. Now, route maps can be used to set actually different things, like different parameters like metric for a protocol in case of redistribution. So if we are actually influencing the metric for a particular protocol, say for EIGRP, and say we are injecting OSPF routes into EIGRP domain, in that case, we can actually set the metric, we can change the metric for the EIGRP by using route map. Now, there is an example also, route map, that we have created the access list standard ACL. We can give a name for the ACL or we can give number, anything we can do. We are permitting the network, say 172.16.1, and then we are creating a route map. Then we are creating the route map as route map set permit 10, means we are permitting that ACL and we are matching that ACL with match IP address. That is, we are matching the ACL R1, that is the ACL. And now we are setting the metric as bandwidth, delay, load, reliability, and MTU. And then we are going to router EIGRP1 and we are redistributing the OSPF1 route using that route map that is set. So we are actually, this is syntax, redistribute, then OSPF1, and then the route map, you give the route map name. So you first make the ACL and you then permit a network, and then you create a route map, and then you match the ACL's route map matching the ACL, and then you set the metric, and then you go to EIGRP domain and you redistribute the OSPF route using this route map, and then these metrics would be reflected in the EIGRP. So that is the theory part behind the redistribution. And now we'll do the practical part of redistribution between EIGRP and OSPF, and also using the route map in the GNS3 simulator. So I have these three routers actually. Let me start these routers. So R1, R2, and R3. Now R1 is connected by fastest line 0 by 0 to 0 by 0, and this is connected from fastest line 1 by 0 to 1 by 0 to R3. Now you can also use serial ports instead of this fastest line links. That is the same thing. Now this R2 is actually the ASBR, and we'll configure R1 and R1 as the EIGRP AS and R3 as the OSPF AS, and then we'll do the mutual redistribution. So let's go to R1. And let's first configure the IP address. Interface first 0 by 0. Shut. IP address 11.0.0.1. I'm giving the default mask. You can give other masks also. You create a loopback interface also. Give an IP address as 1001. And you configure EIGRP domain here. Say router, EIGRP space any S number, say 1. And you insert the networks. One is 11.0.0.0. And the other is a loopback. That is 1000. And now you go to the R3. You go to interface. First is at 1 by 0 in this case. IP address say this is 12.0.0.2. And you create a loopback also. Say 3001. And you configure OSPF here. Say router OSPF 1. And you give network segment as 0000 space 0000 and then area 0. You are using the wildcard. And now the ASBR, this R2 also, this will be 11.0.0.2 and this will be 12.0.0.1. You go to interface F0 by 0. IP address 11.0.0.2. And interface F1 by 0. Say 12.0.0.1. And now you configure EIGRP on F0 by 0 and OSPF on F1 by 0. Network should be 11.0.0.0 for EIGRP. Say the adjacency has already come, and now go to OSPF. And network is 12.0.0.0. And the wildcard mask and area 0. Now, after configuring these EIGRP and OSPF, already the OSPF adjacency has already been done. So now we have to configure the redistribution. First, we'll configure redistribution on this ASBR. So I'm in OSPF 1. I'm in OSPF 1. I'm going to redistribute the EIGRP routes into OSPF. So it's very easy. Now you write redistribute space EIGRP space AS number EIGRP 1 2 EIGRP 1, and you also specify the subnets keyword. Means here in this case we are using the default mask, but in case you are using other subnet mask classless, you need to specify the subnets keyword. Otherwise, it will not be redistributed into OSPF. So it's better to use that. And now go to EIGRP 1 and you redistribute the OSPF routes here. So in this case, you write redistribute OSPF process ID 1, and then you give metric. What are the metrics? Bandwidth, say 1000 kilobits, then delay, say anything. Reliability, say 255 maximum reliability. Load, 100% load, or you can say any 100. And MPU, say 1024. Now we have to verify the redistribution. Now you go to R1 and you give show IP route. Yes, you can see the redistributed route as this external type 3001 and 12000. So here you can write show IP route, and also you can write EIGRP. So that you can also do. Here also you will see the redistributed routes that is coming from the OSPF domains. And now go to the R3, and here also you give show IP route, and here you can see this is the external type 2 route that I was talking about, E2 route 100 and 1100, that has been injected from the EIGRP domain. And you can also give show IP route OSPF to see only the OSPF routes, that is the external routes that is injected into OSPF. These routes are already shown. And you can check the show IP OSPF database, and you give the command, you pipe it and give begin type 5. So you are actually seeing the type 5 external LSA that is being injected from EIGRP domain into the OSPF domain. These are the type 5 external LSAs 1000 and 110. So the mutual redistribution is already happening between the EIGRP and OSPF. Now that is done. So the next step is creating a route map, and we are actually influencing the EIGRP metrics with the route map. So in that case, you again go to the router 2, and here you go to the config mode, and first you create an access list. Say access -list. Say you can give any number, you can give any name also, you can give IP access list, or you can just give access list, say 10. You are permitting that route that was injected into EIGRP, that is 300, this route. So you are permitting 3.0.0.0. And now you create a route map. Say route map, you give any name, say test 1, Then permit 10. This is the first line you are permitting. Sequence number is 10. Match IP address. IP address means the ACL number or the name. In this case, the ACL number is 10. And you are setting the metric value as this one: bandwidth, delay, load, reliability, MQ. So you just give any other metrics. Say we are changing metric to 5,000. Then delay, say anything. I'm changing the values. Load, anything. Reliability, and say MTU. Just give 200. And give anything. Say 1,000, or MTU is 500. I'm just changing the values. Yes. So I've changed the metric, and now you have to again redistribute the OSPF routes into EIGRP using this route map. That's it. And go to router EIGRP1, and you give redistribute, and you are redistributing OSPF routes, OSPF, OSID 1, and then you give route map, just press tab, and route map name, that is, we have created the route map as test1. Now it should change the metric. You go to the R1 router, the EIGRP, and you now again give this show IP route EIGRP, and see this 3001 metric. Has it changed? Yes, it has been changed. Previously it was this 2613760, and now it is 935424. This is changed, okay, because of the metrics that we have changed with route map. So this metric change has happened in case of redistribution. So I've also shown you how to create route maps with redistribution, how to influence the metrics of the EIGRP by creating route maps with redistribution. So I think it was very informative for you, this redistribution and CCNP level. You have this routing, EIGRP, OSPF, then BGP. Many things are there in case of CCNP level. You have the automation, you have multicast, many things, switching, you have the multiple spanning tree protocol, VLANs, many advanced topics of Cisco is discussed there, of the enterprise level, also of the data center level, the security level, many things are there. So I highly recommend CCNP course for everybody of you to get enrolled in the ICSS and to go for CCNP to enhance your career in networking right now. So that is it for the redistribution part that I've already shown you practically, and I've also discussed with you theoretically. So I hope it was informative for you. I hope you have enjoyed this. And if you want more webinars like this and more videos like this, then please go to our channel on YouTube, and also please like and subscribe our channel to get more webinars and videos in the coming weeks on different topics. So thanks for joining this webinar today for redistribution. I hope you have learned a lot about this, and I hope that you will join our CCNP course to learn more about this routing and switching in future very soon. So that is for today. Thank you everybody for joining. I'll come with some other topics some other day. So thanks. Patrick, over to you.
Thank you, Debashish, sir. Thank you, everybody. So it was a wonderful webinar. Redistribution topic was thoroughly explained to our viewers. We ask our viewers, if you have liked the video, please like the like icon, and if you want to know more about it on our videos, please visit our YouTube channel and subscribe to our channel. We also would like you to learn CCNP from our institute. Mr. Debashish Roy is one of the most senior networking trainers, as well as a certified in CompTIA Network Plus and in Amazon AWS as well. If you want to learn more about networking and cloud computing security, then do join Indian Cybersecurity Solutions. Our website is indiancybersecurity.solutions.com. You can call us at a toll-free number at 1-800-123-5014 for more details on our courses on networking. Till then, thank you. Thank you, everybody. Thank you, sir.
Thank you, Peter. Thank you.